Hello students, this is the video for MCQ paper 1 PHY 241 which is oscillations, waves and sound. Question number 1. The maximum velocity of a particle undergoing a SHM, that is simple harmonic motion, is 80 centimeter per second and its acceleration at 4 centimeter from the mean position is 16 centimeter per second square, then its amplitude will be dash centimeter. Okay, so first thing, the formula for the velocity is given by v is equal to omega under root a square minus x square. Now to get the maximum velocity, what is the formula? X is equal to 0. Correct? If x is equal to 0, what we get the formula? For v is equal to a square, this will come 0. A will come out. So v is equal to a omega. This is the formula ready with me. And what is this value given to you? It is 80. Fine. So I'll say this is my equation number 1. Now acceleration, okay, at 4 centimeter from the mean position is 16 centimeter per second square. Okay, which means what? Acceleration is how much? Minus omega square x. Fine. Acceleration is how much? 16. So 16 is equal to minus omega square x. Distance to be 4 centimeter. So I'll say it is 4 centimeter. So from this, how much is my omega square? Omega square will be 4 because 4 4s are 16. Fine. So which means what? Omega is 2 because even though we have a minus sign, okay, in the square root it will be taken care. So this is my equation number 2. So I need to know the amplitude now. Correct? I know v is equal to a omega, I know. So how will I write now? Therefore a omega is 80. A omega is 80, out of which I need to know a. So I'll say omega is equal to 80, a omega is 80. So which means a will be 80 by omega. Omega is how much? 2. Fine. So this will give me how much? 40 centimeter. So here the correct option will be D. What is asked? Its amplitude will be dash centimeters. So amplitude will be 40 centimeters. Fine. Next question. The equation of motion in the critically damped motion is given in the form 13 d2x by dt square plus r dx by dt plus 13x is equal to 0. Fine. The value of r will be dash units. Fine. Now in knowing this, we should know first the value of r. Correct? So what is the usual equation? M d2x by dt square plus r dx by dt plus kx is equal to 0. Fine. From this, what we need to know? We need to know basically the value. So we can say over here, the value will be r square is equal to 4mk. I need to know the value of r. Fine. Okay. How much is m? 13 is m. Plus how much is k? Kx. It is 13. Fine. So this is 4 into 169. Fine. If you multiply this, you get 676. Or we can say 13 twos. Okay. Again, that is 676 only. So this implies, correct? So if r square is 676, r has to be 26 units. This is the way we can solve the answer. So even here also, answer for value of r will be 26 units. Fine. Next question. The frequency of damped oscillator of mass 6 grams is 10 hertz. If the coefficient of damping is 0.314 dynes per centimeter per second or second raised to minus 1, the value of q will be dash. Now in this case, to find out the value of quality factor Q, what is the formula? M omega divided by R, correct? So as usual, what is the M given to you? M is 6 grams. So we can say 6 over here. How much is my coefficient of damping? Coefficient of damping is R, fine. So that value will come here, 0.314. And how much is omega? Omega is here, it's not given. They have directly given you 10 hertz. So we should know the formula that omega is 2 pi nu, correct? So 2 into 3.14 into nu is 10 hertz. So if you multiply this, we are going to get the answer to be, this is 4 2s are 8, 2, and this is 6 into 10 will give me, multiply by 10 will give me 62.8. So put the value over here. Okay, so if you simplify this, check it out on your own also. Okay, so this comes out to be 1200. So therefore answer A is correct. So this is the way we can solve the problems in the paper which is there on 31st of August. Fine. I think last semester my MCQ videos were quite helpful. That's what I got to know the response. That's why I thought now also I should make it and make your life a little more easier. Okay. So these are the first 3 questions. We'll move to question number 4. So question number 4 is the amplitude of oscillation for a driven oscillator, fine, given as 4 d2x by dt square plus 4 dx by dt plus 64x is 3.x sine 4t will be dash meter. So I need amplitude over here, fine. So to knowing the amplitude, I need to know the formula. Okay, the formula for the equation, what is the equation? M d2x by dt square plus r dx by dt plus kx is equal to f0 sine qt. Okay, so to know the amplitude, the formula is given by A is equal to f0 divided by under root k minus mq square bracket square plus r square q square. This is the formula for knowing A, fine. So over here, how much is f0 given to you? F0 is this. So put the value 3.6 divided by under root. How much is k? I told you kx. So 64 minus, what is m? M is 4. How much is q? Is 4, but q square, so this should be 16 bracket square plus r square. How much is r? Is 4. 4 square should be 16 into q square. How much is q? Is 4. 4 4 is 16, fine. So this is 64, this is 64, this term will get cancelled, fine. So how much is left? A is equal to 3.6 divided by under root 16 into 16. Okay, so outside it will come 4 into 4. So here it will be 16. So if you divide this 3.6 by 16, you should get the answer 0.225. So that's why the answer B is correct, 0.225 in meters. Obviously not given because here it's, I mentioned it very clearly how much meters. Right? Next question, question number 5. An alternating EMF, okay, of amplitude 230 volts is applied to series LCR circuit with L is equal to 20 millihenry, C is 2 microfarad and R is 50 ohm LCR circuit. The resonant angular frequency omega 0 in radians per second will be how much? That's what is the question. Okay, so the resonant angular frequency formula is basically omega 0. Don't get confused between F and omega 0. So what is omega 0 formula? Is 1 upon under root LC. If you ask F, not resonant angular frequency, that should be 1 upon 2 pi under root 1 upon LC. Okay, so this you should be very careful what formula you are choosing. So how much is L? We said it's 20 millihenry. So 20 into 10 to the power minus 3 Henry multiplied by 2 into 10 to the power minus 6 farads. Correct? So if you simplify this, what you should be getting? This is nothing but 20 to the 40, 10 to the power minus 9, or we can say under root 4, 10 to the power minus 8. Fine. So if you do that, we get 1 by 2 into 10 to the power minus 4. Fine. Or 1 by 2 is how much? 0.5, 10 to the power plus 4. Okay. Fine. Okay. How much means this? This will be 5000. 5 by 10 or 5 to the power 1. Okay. 5 by 10 will be like 1 by 2. Okay. So therefore 5000 is the perfect answer. Okay. Afterwards we'll go to the next question, which is calculate the energy density of a plane progressive wave of frequency 300 Hertz of amplitude 0.07 centimeter. Correct? The density of the medium is 1.293 into 10 to the power minus 3 grams per centimeter cube. Okay? So here we need to calculate basically the energy density. Fine? So knowing the energy density, we need to know the formula first. What is the formula? C is equal to under root T by mu. Fine? How much is T given to you? T is straightforward given out to be around. T is given out to be, how much is the value? The formula for, I made a mistake, I wrote a wrong formula. The formula for energy density is E nu is equal to 2 pi square nu square rho into a square. Okay. Now whatever is given, that we'll write first. So 2 into 3.14 bracket square into nu. How much is nu, or the frequency given to you? It is 300 Hertz. So we'll write 300 into nu. What is the density given over here? It is density of the medium is 1.293 into 10 to the power minus 3 into a square. How much is a given to you? 0.07 bracket square. So if you simplify this, we should be getting the answer 11.26 ergs per centimeter cube, because this is energy density centimeter cube. So therefore, out of the 4 options given to you, option B is perfect, 11.26 ergs per centimeter cube. Okay. We'll move to the next question, question number 7. Question number 7 is a metal wire of length 30 centimeter weighs 3 grams. If it is stretched by a force of 10 newtons, then the speed of a transverse wave passing on it will be dash meters per second. A simple question. Okay. So here the formula should be C is equal to under root T by mu. Okay. But how much is mu basically? Mu is mass per unit length. So how much is mass given to you? Mass is given out to be 3 grams. So we'll have to convert it into kg. So this will be 0.003 divided by length. Length is how much? It's 30 centimeter. Even that we'll have to make it in meters. So 0.3. Okay. So if you divide this, we will getting the answer 0.001. This is my mass per unit length, mu. So therefore C will be how much? Under root T. T is how much? 10 newtons. So 10 newtons divided by 0.01 will give me under root 1000, which is 31.62 meters per second. Therefore the correct option is C over here, 31.62. Right? We'll move towards the question number 8 now. Calculate the change in intensity level when the intensity of sound increases by 10 to the power 4 times its original intensity. That's the simplest question has been asked. So first we'll write down the formula. What is the formula to find out intensity level? Intensity level is 10 log to the base 10 I by I0. Okay, and how much I by I0 is given out to you? I by I0 is 10 to the power 4. Substitute the value over here, so you get 10 log to the base 10 to the power 4. Correct? So how will you solve this? This will be 10 into 4 log to the base 10 of 10. So this will give me 40 into 1, that is 40 dB. Correct? Log 10 to the base 10 will be 1. Fine. So therefore answer E is correct in this case. Question number 9 now. Determine the reverberation time of a hall of capacity 56,000 cubic feet if it contains sound absorbing material of area 7,000 square feet having absorption coefficient 0.2. I need to know reverberation time. So what is the formula for reverberation time? There are two formulas, one for the cubic feet and one for the meter cube. Fine. So therefore we'll write formula first, 0.05 V by A. I need to know T. So how much is V given to you? 0.05 into 56,000 divided by A. How much is A now? What is the formula for A? A is basically capital S by A. So over here, this is what? Effective area. This is the area given and this is coefficient of absorption. So in this case, how much absorbing material of area is given? 7,000 square foot. So S is 7,000. Fine. And absorption coefficient 0.2. So if you simplify this, cancel this 3 with this 3, 7, 8 are 56. So multiply this and this is 0.2. You get the answer to be around 2 seconds exactly. Check it out. So therefore answer B is perfect. So this is our 9th question. Okay, in this case I am covering from chapter 1 to 5, not only one chapter, all questions together. No, because this is the practice for examination now. So this is the way I feel this is perfect. Okay, now we'll move to question number 10. Question number 10 is, a spectral line normally at 4000 angstrom unit is shifted to 3999 angstrom unit by relative motion of source. What is the velocity of source along the line of sight? That's a simple question asked over here. So what is the formula? Velocity is asked. So V is equal to C into delta lambda by lambda. Now how much is C value? Which is 3 into 10 to the power 8. How much is delta lambda? 4000 minus 3999, which is 1 angstrom. And how much is lambda? Lambda is 3999. Fine. So if you simplify this, okay, you will be getting the answer exactly 7.5 into 10 to the power 4 meters per second. Now the calculus are allowed, so this is not difficult for you to divide this and get the answer. So therefore the perfect answer is C, 7.5 10 to the power 4 meters per second. Right? We'll move to question number 11. Question number 11 is what? Sounds of frequency higher than 20,000 hertz which are inaudible to normal human ear are called dash. Okay, now we know the human being can hear the frequency range from 20 hertz to 20 kilohertz, but this is higher than 20 kilohertz. Okay, so higher than 20 kilohertz is nothing but ultrasonic. This is again the electromagnetic spectrum. If you know, this is not difficult to solve it. Okay, now we'll move to question number 12. Question number 12 says, a cinema theater has a volume of 750 meter cube. What should be the total absorption in the theater if the reverberation time of 1.5 seconds is to be maintained? This is the question asked. So to do this, first we'll have to write the formula for reverberation time, which is 0.161 into V by A. Now why I change the formula? Because the values are given in volume to be in meter cube and absorption or the area should be again in the meter square. Fine. So in this case, what I'll have to do, I know the value of T and V, I do not know A. Fine. So change the formula first. So this implies A is equal to 0.161 into V divided by T. Substitute the value for V and T. So 0.161 into V. How much is V? 750 meter cube divided by T. How much is T? Given over here now. Reverberation time is 1.5 seconds. Okay. So simplify this. We will be getting the total absorption in the theater. We need to find out. So this will be called as 80.5 open window unit. This is the word they are using in this case. So, or it is not mentioned anything, it's also okay, but it is actually 80.5. So answer is D, open window unit. Okay. Question number 13. In a damped harmonic oscillator, the damping force R, the damping force is proportional to displacement, velocity, acceleration, and none of this. So everybody knows that the term m d2 x by dt square plus r dx by dt plus kx is equal to f0 sine qt for the damped harmonic oscillator. So R, the damping force, is always proportional to velocity. Correct? Therefore, the answer is 13 is perfect. Okay. Then we'll go to question number 14. Question number 14 is the frequency of oscillations of a particle is 0.2 hertz. Fine. Its time period is dash. Simple question. So I need to know the time period. So I'll say capital T is equal to 1 upon nu. Correct? That is frequency. So simple calculation. So 1 upon 0.2 hertz. So this will give me simply, correct, 0.2. So 2 by 10. So 10 by 2. So this will be give me 5 seconds. As simple as that. Okay. But you should know exactly what is asked. So it will be easy for you to find out. Right? Next question. Keeping the R constant, if mass of the oscillator is doubled, then logarithmic decrement is dash. Is it doubled, no change, halved, or increases? Okay. First of all, we'll write down the mass of the oscillator. What is the formula for this thing, logarithmic decrement? Logarithmic decrement is given by basically RT by 4m. Correct? Now what they say, keeping R constant doesn't make any difference. If mass of the mass is down, if it is doubled, becomes 2m, definitely this part is going to reduce. Correct? It's obvious. So we can say if this doubles, this has to be half. So answer is C. Okay? This is the way we will be solving the more MCQs in the upcoming video. So today we have finished total 15 questions. Go through it. Okay? We will continue in tomorrow, and at least 2-3 days I'll be taking, by which we'll finish till 50 questions. Okay? If the response is good, I'll be also happy to carry on with my work. Fine? Thank you very much.